Okay, the question was, you have salespeople with a certain mean sales and a normal distribution with a certain standard deviation. Now I kind of rounded the numbers off a little bit. The mean was 9,000. The standard deviation was something like 3,646 or something like that. And I rounded it off to 3,600 just to keep the numbers easy. So what you have now, you have 38 salespeople. Get that in your head, imagine 38 people. And a mean sales of 9,000 with a standard deviation of 3,600. You should immediately draw your normal distribution for that information. As soon as you see it, you draw your normal distribution. Then we start asking questions that are related to the ultimate question, which is, how much would the top person sell if this distribution is valid? How much would you expect the person with the greatest sales to have been able to sell? Okay. Well, we draw the normal curve, very straightforward. Z value has gone from -2 to 2, and we try to do an accurate normal curve. We've done that dozens of times by now. And then we label our x's. Our mean was 9,000, so that goes at z equals 0. Then we got to move 3,600 for every standard deviation, so z equals 1 is going to be 12,600. And another standard deviation takes us up to z equals 2, which is going to be 16,200. And then we move 3,600 to the left and another 3,600 to the left, and we get our -2 and -1 x values. 1,800 for -2, z equals -2, and 5,400 for z equals -1. Okay, well, we've got 38 employees. The question is then, what percent of the area corresponds to the top employee? Okay. Well, let's just think about what the areas mean in this context. We want to understand why. I could tell you very easily how to calculate this, but it wouldn't necessarily have any meaning. Okay? So we want to understand the question of what percent of the sales employees would be the top salesperson. Okay, so I start with the question, how many are in the top 50% of the sales force? Now, people had a little trouble with this and actually went to their calculators to do it. Well, okay. I don't like to see you doing things with a calculator that you can do in your head. If you reach for your calculator to take 50% of 38, you really need to be thinking more arithmetic. Okay, well, top 50%, that's the top half, isn't it? 50% is half of your sales force. So the top 50%, that would be from here all the way over. How many would that be? That'd be 50% of your employees. 50% of 38 is half of 38. Okay? There are many ways to calculate half of 38 without reaching for a machine. Okay? Half of 30 is 15. Half of 8 is 4. 15 plus 4 is 19. Or 38 is 2 less than 40. Half of 40 is 20. Half of 2 less is 1 less. 1 less than 20 is 19. You can do a long division. 2 into 3 goes 1 time, and then 3 minus 2 is 1, and 18, 2 goes into 18 9 times. You can do that if you have to. Incidentally, who's the top sales Perón? He was Argentinian dictator, and we're talking about person, we're not talking about Argentinian dictators. Okay. So, well, anyhow, the top 50% is the top half, that would be 19. That's not the top person, is it? Top 50% would be 19 people, not just one person. Okay, well, what percent would be the top one person? Well, let's narrow it down a little bit. Let's go to the top 10%. How many in the top 10%? Now, again, you shouldn't have to reach for your calculator to take 10%. That's just 1/10. And you should be able to divide by 10 easily. So 38, 10% of 38 is 3.8. I'm not going to explain that. You need to understand that thoroughly. Okay? So the top 10% would be the top 3.8. Well, that rounds off to 4. It would be about the top 4. So your top 4 people make up your top 10%. Okay? Well, your top person would be 1/4 of the top 4. So why don't we think about the top 1/4 of 10%? How many percent would that be? Well, 1/4 of 10 is 2.5. Okay? So the top person among the top 4 is the top 1/4 of the top 4. So it'd be the top 1/4 of the top 10%, and that would be the top 2.5%. Well, you make a pretty good estimate then if you use the top 2.5%. And what would that say? That would say on the normal curve, you want just 2.5%, 1/40th of the total area, to be to the right of that curve. That would correspond to your top person. Okay? Now it actually turns out we want 0.026, 2.6%, for reasons I'll explain in a minute. But that's going to be pretty close. It's not going to change the picture. Right there is the part of your curve that represents your top person. Now if you want to really calculate it, the top 1 out of 38, well, that's 1/38th of your group, which is 0.026 of your group, or 2.6% of your group. That's why I say, well, this area should be 0.026 of the total. Okay, well, having gotten that, we want to figure out just where this is in the curve. If we know exactly where it is, we can figure out what X number goes with it. How can we use the z-table? Well, the z-table will give you the area between here and here. Okay, if you use the area between here and here and look up the corresponding z-value, you'll get the z-value. And you can use that with the mean and the standard deviation to figure out what the X value would be here. Okay, so how much area here? Well, if 0.026 of it is here, well, half of it is from here to here. So this area has to be 0.500, which is half, minus the 0.026 that corresponds to your top person. That would be 0.474. Okay, so we look at the z-table. Now, I used the z-table that you're going to have on the test, and it's here. Now, let's see, okay. And I don't know that you can read it, but what we do is we find area 0.474 and see what z-value goes with it. That's going to be our z-value for the top person. Okay, well, 0.474. Okay, now you might not be able to read this. Actually, we got pretty good resolution here, so you might, if the camera focuses. Right here is that number. Now, how do we find the z that goes with this? Because this isn't exactly like the table in your book. Well, z values are over here. So we come over from here and we find that the z value is 1.9. However, we have a bunch of columns next to 1.9. Okay, reading from 0.00, 0.01, 0.02 up to 0.09. We see that our number lies in the column that's labeled 0.04. So we have 1.9, but we have another 0.04 on our z-value. Okay, so the two numbers we get in our table, and here I've indicated it. First place, we don't get exactly 0.474, we get 0.4738, but that rounds to 0.474, and it's real close. We come over to the z-values, and we get 1.9. And then we have our hundreds that go from 0, 0 to 0.4 to 0.9, 0.009, and so forth. Okay? And we find that this lies below 0.04. So our z-value that I've written here is then the 1.9 plus the 0.04, or 1.94. Okay, so now we know the z-value here. And we see that that's 1.94, so we're a lot closer to 2 than we are to 1. Which means we're a lot closer to the X value, 16,200, which corresponds to z equals 2, than we are to 12,600, which corresponds to z equals 1. So we think, Now then there's round number, 16,000. We're pretty close to 16,2, so let's round off and say 16,000. Just coincidentally, it turns out that that's really, really close. So, we make our estimate between 12,6 and 16,2, much closer to 16,2. So we say our estimate is 16,000. I don't know that I ever actually wrote out 16,000, but that was the estimate we came up with. Now, how do we calculate that? Well, X is 1.94 standard deviations from the mean. Okay, Z equals 1.94 means 1.94 standard deviations. Standard deviation is 3,600. So X has to be 1.94 times 3,600 greater than the mean. Okay? Well, 1.94 times 3,600 is pretty close to 7,000, which means that this guy's got to sell the mean, 9,000, plus the 7,000. That's the difference, the X difference from the mean, which is 16,000. And I think this actually comes out 15,984. That's a fairly easy estimate. 0.06 times 3,600 is 144. Okay. No, it isn't. Wait, 36, 6, sorry, it's 0.216. Yeah, it is. 216. Yeah, 216. And 216 subtracted from 7,200 is 69,84. Add that to 9,000, you get 15,984, which is what I said. So somehow I got that right. Okay, well, that's the picture. Now I have a statement here that I didn't complete, so let's just, for area points 474, the table gives us Z equals 1.94. I didn't complete that because people had a little trouble adapting to the table. We took just a little bit of class time. It did take people long to figure out how the table was set up. And that is a very common way, this is a very common way for tables to be set up. The table in your book lists more Z values than necessary. And people were very affectionate toward that table, but I think everybody understands how this works, and everybody can see from the table in the book how you get the same result.